Hey students, in this video I'm going to explain the next part of absolute value functions, which is transformations. So it's a continuation of what we were doing in Unit 2. At the top we just have an example of what the parent function for absolute value functions look like. On this top right, it's just in general the template that was shown to you about each part, A, B, H, and K. And if you need to look at your notes from that from Unit 2, just make sure you pull those out. Also, the table that had all the descriptions there is given. And now we just practice. So I'm going to go over the two examples right here, and the two examples on the top, and the two examples on this left side. You take care of practicing the ones on the right side. So on the bottom left, we have two equations given to us, and they're asking you to describe the transformations of the parent function. So here they are giving you a parent function. So you don't have to think of typing anything in general. Just absolute value of x is what you're going to type. So in your calculator, make sure you have that ready. If you don't have a calculator because you're watching this at home, you can always go to Desmos calculator and type this. So absolute value of x is what we have as a parent function. So we're going to go ahead and type that. And from there, we're going to have this new graph. So on tab, you're going to now on second equation, type this. Absolute value x plus 3 minus 4. So after you type that, it looks definitely like it went down and left. And if you recall from the template of transformations, a, f, b, x minus h plus k, right now you can tell that the only numbers that were given to you were 3 and 4, which means h and k. And h and k, according to the notes, h and k are translations left and right and up and down. So yes, definitely that h affected by moving left or right. So definitely the graph shows us left. So we're going to say that it shifts left 3 units. And then the k is telling us -4. So that's going to say and down 4 units. And that's it. That's the transformations descriptions for that first problem. All right, so let's try the next one. So we're going to leave the parent function alone, and we're going to go ahead and edit that second equation that we typed. And we're going to type negative absolute value of 2x. And then this is what it looks like. So definitely reflected over the x. And as you can tell from the template, this is true because it affected the a value. That negative in the front is the a value, and that 2 on the inside is the b value. So you have to say that the a being negative made it reflect over the x-axis. And then as far as what that 2 did, remember 2 is a b value, so b values are described as dilations of horizontal changes. So we gotta say horizontal or horizontally, and then we have to decide if it's compressed or stretched. So if you want to compare it directly to the parent function, double click that and delete the negative. So it can delete the reflection, and then now you have a perfect view of how it made it thinner. So horizontally, it made it go in. So that compressed it. Horizontally compression by, and then you have to say scale factor of 1 over b. So your b value is a 2. So we're going to say by 1 over 2. So this is the description for that second problem. All right, so now you try these two problems right here. Pause the video if you need to. On the back, now you have the descriptions given to you, and you need to write the equation. So start by writing the parent absolute value function, which is y equals absolute value of x. And then maybe even writing the template again, it helps. A, f, b, x minus h plus k. And then as you read, kind of underline or circle or highlight what keywords you have as far as changes. So it says it translated 1 unit right. So that would mean that the H is affected. And then it vertically meaning the A value, because B is horizontally, stretched by a factor of 6, and then reflected over the x-axis. So x-axis, reflection over the x, is still the A value. Over x-axis is still the A value in the front. So that means we're going to have a negative in the front, negative, and then the A value has to be vertically stretched by 6. So we're going to put it 6 in the front, absolute value of x. If it translated 1 unit to the right, we need to show that we went to the right 1 time. So we're going to put in here for h a positive 1. So if we put a positive 1, then we're going to have x minus 1. There is no k value, there is no b value, so then we just have this as our transformation. So y equals -6 absolute value of x minus 1. So that looks a little bit weird, so I'll just write it again. Y equals -6 absolute value of x minus 1. All right, so the next example we're going to have is the parent absolute value function. So once again, y equals absolute value of x is horizontally stretched. So now if I write my template, I'm going to have a horizontal change, which means the b value, horizontal stretch by a factor of 2. So remember, when we say factors, we got to say 1 over b. So if you have a 2, that means we need to have 1 divided by a number to equal 2. So it's not 1 divided by 2, it's 1 divided by a number to equal 2. This is a little bit hard to understand, but if you've done the practice that I've given you, you may recall that when you divide by a fraction, it becomes a whole number. So if 1 divided by 1/2 is 2, that means b value is 1/2. So I'm going to know that my b value is 1/2 x, and then it says reflected over the y-axis. So that reflection over the y-axis is also a b value. So that means I'm going to erase this line and scoot it over and put a -1/2 x and shift it up to units. So I can close this because I know that my up to units, it's my k value. So I'm not going to need h, I'm not going to need a, and I'm going to put up to units, so plus 2. So y equals absolute value of -1/2 x plus 2. That will be my answer. So try these 2 examples right here on the right side and let me know if you need help. On the last 2, we have the graphs, and you just have to describe or actually write an equation of the transformation from the parent function. So keep in mind that the parent function is starting at the origin, and it's a 1-to-1 ratio. And by 1-to-1, like I said, it's a slope of a line, rise 1, run 1, rise 1, run 1. So this is the parent function. Any chance you get, if you can plot it real quick, plot it. So now you notice that this is exactly the same angle as this line. So it didn't change in dilation, it just changed in shifting down. So because it shifted down, you just gotta say how many spaces. 1, 2, 3. It shifted down 3 spaces. So on the template of A, F, B, X minus H plus K, down is only affected on the K. So everything else, we don't need to write an A, we don't need to write a B, we don't have to write an H. And like I said, F is not needed if you're just going to use absolute value of X. So if we're going to put a down 3, we're going to put -3. So y equals absolute value of X minus 3. That's the equation for that. All right, so for the next one, let's do it again. Parent function starts at 0. Rise over run is 1. 1 over 1, 1 over 1. Same thing on the other side. So definitely, if you look at this, the angle of steepness of the line did change. It's not following the 1/1 ratio. It looks like it shifted a little bit. We just have to describe it as vertically stretched or vertically compressed. I believe in absolute value functions, we don't really have b values most of the time. We just have a values. So let's just stick to a, absolute value of x minus h plus k. I believe this will be the template for absolute value transformations. So definitely the origin, the vertex went from 0, 0 to now this point right here, and that is your HK. So H is your X, and then K is your Y. So 1, 2, 3, that is your H, and then 1, 2, that is your K. So I just want you to see how H and K, X and Y, 3 and 2, it's that vertex right there. So I'm going to write down in here and in here, that 3 and that 2. So I'm going to have absolute value of x minus 3, close it, plus 2. And then as far as that a value, we need to look at the slope of the line. So from this point, it goes to this point. And it looks like on the other side, it also does that. So rise over run is 1/2. 1/2. That's the a value that you have. So like I said, the a value is like a slope from one point to another. All right, so I hope this video helps. Rewatch it if you need to, but go ahead and try these 2 examples. And please let me know if you have any questions. And I'll see you.